Good morning. I hope you've had a chance to look at this cartoon. I'm actually using quite a few cartoons to make this more interesting. And just to say that I won't be reading out cartoons or jokes because you can all read and you're all watching your screen, so you'll be able to read them for yourselves. So don't say that. Teacher, will we ever use any of this algebra? You won't, but one of the smart kids might. Don't say that. Obviously, and I'm sure we've never said this, we don't expect much of you just because the girl is blonde. And of course, why do I do algebra? And it's important to learn maths because someday you might accidentally buy a phone without a calculator. And why is it important for today's kids to learn algebra? Just because I had to learn this junk at school and now it's your turn, that's why. So I'm sure none of you would say any of these things, but equally, please, we're going to talk about things we shouldn't say to youngsters. How many of us at some point have said to a very young child, you always take the small number and the big number? I found myself saying that to our granddaughter when she was 5 and pulling myself up short and saying, don't say that. The more digits there are, the bigger the number. Again, a very easy thing for a primary school teacher to say to her class, because it's true when we're talking about thousands, hundreds, tens and units, but not once they go on to decimals. To multiply by 10. I was taught that rule at school, were you? To multiply by 10, simply add a 0 to the end of the number. And to divide by 10, take off the last number, and that becomes the remainder. All things are very, very easy to say, but then children internalize those, and then they keep that understanding. The problem I always think is, as mainly a secondary teacher, is that the children adore their first teacher. She's usually a miss, and she was just lovely, and she told them these things. And then you come along in year 8 or 9 and say, that's not true. Well, who am I going to believe as a student? I'm going to believe that lovely Miss So-and-so because she never raised her voice. She didn't ask me to do difficult things. So I'll go along with what she says. So it's very easy for us to say things to children. We borrow a 10. Do we give it back? That's how I was taught, borrowing and paying back. Doesn't make sense. When you multiply two numbers together, you always get a bigger number. And what other rules do we give children that don't work in later life? So I'm going to ask you to go to the chat box, which I hope you have, and put into it other suggestions. We're going to save these all and I'll write them up after and share them with you all. So I'm going to give you a couple of minutes to write down in the chat box your suggestions. What rules do we give children that don't work in their later maths life? Can they see their chat? All right. Nod if it's okay, Chris. Thank you. Suggestions seem to be drying up. You can always put one in later if you think of something. Don't imply that. How many students did I have when I was teaching in sixth form college that used equals to mean this is the next thing I thought of? And I would try and persuade them that equals was different, but no, they were absolutely sure that it meant this is the next thing I've thought of. Fractions are always parts of pizzas because they've been introduced to fractions as parts of a pizza, and so they think that's what they're all about. Mass is the same as weight. I thought that for a long time myself. And the number system, our number system starts at 0. There isn't anything before because the number line that was up in my classroom when I was little definitely started at 0. They didn't have any of this negative stuff that you're talking about now. This I found as a cartoon. Person saying they don't use 6 because they heard that 6 died in a road accident. We may laugh at that, but one of my colleagues a few years ago came back to tell us that he had found a girl that didn't use 13 at all. This girl was in about year 9, so she was about 14 or 15, and someone had told her when she was little that 13 was very unlucky and that it wasn't used for a hotel bedroom ever, and sometimes 13 is missing from streets. So she had internalized this, and my colleague discovered that when she counted 9, 10, 11, 12, 14, and when she worked out any sum or any, I shouldn't use the word sum because someone was telling me off for that, when they worked out anything and got the answer 13, she just went up to 14 or down to 12. So actually her mathematical understanding was quite good, but unfortunately she did get a lot of things wrong because she didn't use 30. So it isn't just a joke. Someone did exist who did that. Children can also jump to conclusions. When asked how many sides do these triangles have, in a piece of research, they found that many of the children said A has 2 sides because it also has a bottom. B has 2 sides and a top, and C has 3 sides. And again, how many children do you think that hexagons or pentagons or octagons always have equal sides? Because they never meet an irregular one. A lot of children asked to draw a triangle think they all look like the one at the top. And all right angles look like that one, or like, so I've got to go the other way, haven't I? That one. Because that's all they ever see, particularly in textbooks. That parallel lines are always like that or like that, and that therefore these lines are not parallel because they're not going that way or that way. And you never, ever get a minus sign at the beginning of an equation. How many textbooks have a minus sign at the beginning of an equation? Very, very few. Some more recent ones may, but for a long time, textbook printers and examination papers never, ever had minus a sign at the beginning of the equation because they were worried that it would be misread as a dash. And so they just didn't exist. And so a lot of students I found didn't believe that you could actually have one at the beginning because they have never seen an equation with a minus sign, a quadratic, for example, with a minus sign at the beginning. Just another cartoon to make you smile, I hope. Now, I just want to talk about mathematical language for a few minutes. Could you all close your eyes and visualize a log? And now visualize some log tables. Did you see a log like this and even perhaps some log tables like this? Or did you visualize log tables like those? Many words mean something different in the math classroom. So when you say to your pupils, always label your axes, what kind of axes are they thinking of? A few years ago, I started collecting a list of words that mean something in maths world, but something else in the rest of the world. And I got up to 100 and something, and unfortunately I've lost the list. So I started writing a little list of my own when I was preparing this talk. So when I'm reading through them, I want you to think of the maths word, complex. He's got a complex about that. And oh, she was awarded a degree. If you go into the staff room and start talking about differentiation, I will think that your colleagues in the English department will be thinking of something completely different from you. I've got a digit and I've even got a piece of paper here. We in Scotland, we know about a factor who looks after a building or an estate. Function, I can tell you a joke about function later on. He's rather gross, isn't he? I guess, again, integration will mean something very different. How do we integrate the new member of staff? I've got a key to my door. And of course, there's always the worry about whether it's a meter or a gas meter. He is rather odd sometimes, isn't he? And my friend had an operation because she had a kidney stone. And the power, well, I've got electric power coming into our house. We don't have any gas here. And I did like the plot of the film that I watched last night. And he's in his prime. I do have a problem with her sometimes, though. And I do like the product that Persil make. And it's quite different in the real world, isn't it? And our vegetables have roots. And I'm sitting with a table in front of me. And we're watching, and we watched the Line of Duty series recently. And could you turn up the volume on the radio, please? And maybe if you're American, go out to the yard. Classroom and means something in the rest of the world. Could you put them into the chat box? And let's see if at the end of this session, we can get up to the 100+ words that I managed to do before. So I'll give you to do that. Words that mean different things in math to everyone else, please. Right, I'm going to stop you there. Again, if you think of others, please put them into the chat and I will gather them all together after this session. So, math jokes. I just thought we needed a little interval now. I always used to talk about the complementary angle who was saying to the cute little angle, wow, you do look good today. And I like this good old 3 and 7 are, good old 7 was in prime form tonight. They just strike me as such an odd couple. This is one for you, Chris. And then, of course, we get the jokes that only people that teach maths will understand. Like this one with the maths book saying to the physics books, I hate you, Kyle. You just used me to get to her. And so some maths jokes do rely on higher knowledge of mathematics. The one about the sheepdog who was asked to go and by the shepherd to round up the sheep. And the sheepdog comes back and says to the shepherd, because he's a talking sheepdog, I've just brought in 40 sheep. And the shepherd says, but we've only got 38 sheep. And the sheepdog said, but you asked me to round them up. Or a friend of mine, I remember coming into a conference going, at last I found someone that I can tell 2 jokes to, because most people won't understand these ones. And she told me the jokes about when e to the x and sine x and cos x and tan x and lin x all went out for the evening dancing. And suddenly cos x looked over and e to the x was sitting in a corner all by himself. Come on, he said, come on, come and integrate. And e to the x said, with a tear running down his cheek, it wouldn't make any difference. But luckily plus C was sitting beside him. And the next night they all went out to a bar, and one of them, probably sine x, strode up and started ordering drinks. And the barman said, sorry, we don't serve functions here. So do say that. I want to then go on to what we should be saying in the maths classroom. I just put in this joke though, which you can think about for a moment. The Pygmalion effect. It's worth talking about one of the things we should be saying is encouraging students. The Pygmalion effect was a study carried out in 1963 at an elementary school south of San Francisco. And they wanted to find out if teachers would react differently towards certain students if they were told certain things about them. So Rosenthal issued an IQ test to all students at the beginning of the year. And after they'd completed it, and teachers knew that the students had done this test, they actually chose students at random to be what they called academic bloomers. They told the teachers that these students were excellent, really good students. And then at the end of the year, they tested the children again. And what they found was that especially in younger children, like those in grades 1 and 2, there was a remarkable difference in the IQ between the students chosen to be academic bloomers and those who were not. The reason was that younger children were more influenced by their teachers. So this is called the Pygmalion effect, which is the phenomenon that explains better performances by people where greater expectations are put on them, because they discovered that the teachers were paying more attention to these students, they were expecting more of them, and the result was they did better. So telling students that, as I said in my keynote, when I had the disaffected youngsters from our feeder schools, I used to tell them that they were doing really well. I used to make sure, I used to give them certificates if they'd done good work. And I would award those, a life certificate with our logo, our badge at the top and so on, from the maths department. But I would send it to their head teacher and ask them to present it to them in an assembly. And they would come back and they would say, Miss, I've never had a certificate before. My mum's framed it. She's so thrilled because now, and they suddenly began to believe that they could do maths. So suggestion has a really important influence. A few years ago, I was involved in a project with someone who really believed in neuro-linguistic programming. And the idea was to look and see whether we could raise maths attainment by teaching teachers how to use these techniques. It was, the experiment was done with adult learners and their teachers. It was carried out over a 6-month period. It was quite unusual as an education project or research project because we had a control group. And we had large enough numbers that our results were significant. And these were the maths attainment before and after. So we had 3 groups. We had a group who had no training, no input from us at all. And as you can see, their students still improved. We then had 2 other groups. One group who had spent 3 days with me looking at maths activities. This was based on improving learning in maths, looking at activities they might do, talking about questioning, talking about using prior knowledge, etc. And as you can see, they improved, they started worse than the group that had no training, and they actually caught up with them. They improved quite a lot. And then the final group was a group where they had the same day's input, the same days with me, but they also spent so many days with Richard Church's being trained in neurolinguistics. And as you can see, their results soared. One thing I did learn from this, we presented our results at a conference and we invited all the teachers. The ones with no training were actually told they would get the training the following year, and they did. But they came, and unfortunately, we'd allowed them to sit in a group, and they were sitting at the front. And when I presented these results, some of them were absolutely furious that their students haven't done as well as the others. So that's what I learned. Never invite the group that you're exposed to a thing like this. But as I said to them, your students still improved, which was good. So as a result of that neurolinguistic programming, the teachers produced a set of cards for other people to use. I do have these not in card form, but I have them in paper form. And when I share my PowerPoint, I will also share the cards. So I want to look at just some of the cards that we've got. So the principle of suggestion, as defined by NLP, is that there is always a deeper structure to words. It's about, so we need to, just notice the difference. If you do this, you might. When you do this, you will. And of course, the second one is so much more positive. So when I'm going through the cards, and I'm just going through some of the cards today, and the things to notice are in bold, and the embedded commands and suggestions are underlined. First of all, though, I would like you all not to think of chocolate. Please don't visualize chocolate. Just don't think about chocolate for the next moment. And unfortunately, I think most of you will have found that you can't not think of something. It's very difficult not to think of something. So if you say, I'm not suggesting you will understand division straight away, you can actually get them thinking that they will understand it. So always remember to say what you want, not what you don't want. It's if you suggest something. One of our lecturers at university in psychology said to us, if there's bad behavior, ignore it. And I'd never tried that properly until I had a very badly behaved class one year. And I did ignore their bad behavior. I praised good behavior. I told them when they were doing really well. I lied through my teeth to them about how well they were doing. And do you know their behavior actually changed? I was quite amazed about that. Attributing something to someone else makes it easier for people to accept. Which is why, and one of the reasons why I used that quote by Anne Watson this morning, to say Anne Watson, the professor at Oxford University, she says that every child can succeed at maths or can make progress in maths. Saying something someone else has said is always very useful. I should say that I'm not going to read these slides to you. Again, you can read, so please read them for yourselves. Getting learners to pretend things in their mind so their focus is in what is possible. Just pretend for a moment that you already know how to use this sort of maths in everyday life. Suggestive language. The order of words is important. In some schools of hypnosis, for a suggestion to be received in a person's unconscious mind. Principles of suggestion, as defined by NLP, is that there's a surface structure to language, the actual words, and a deeper structure, their meaning and what is suggested. This is the easiest way, isn't it? It's the same as saying, isn't this the easiest way? Suggestions, the art of putting your instructions into the deep structure that reflect what you want and avoid implying what you don't want. Don't use words that imply you might fail. So if you do this, you might does imply that they might fail at the task. And mentioning positive states of mind can bring them to the attention of your learners and influence the mood in the classroom. It's good to know that if you read the questions carefully, you might get them right more often. Yet is a very powerful word. It's got a lovely suggestion or presupposition built into it that suggests something might be possible in the future. So if you use yet at the end, it implies that in the future, they'll be able to do it. So could you write your own example or think of your own example? Think of a sentence starting, it's good to know that, or a sentence ending yet, which you could use in your classroom and write it into the chat box. Give you just a minute to do that, or just to think about it. Again, we can presuppose success by sooner or later you will know how to do this. And everyone who learns this eventually looks back and is surprised why they thought it was so difficult. These sentences, again, all encourage your learners. Similarly, a generalization. Many people have overcome the challenge of this. Everyone who's used this method has found it's the best way to do it. So again, saying that lots of people, other people can do it, does encourage you to think, well, maybe I can do it as well. Mind reading involves pretending that you know what some of your audience are thinking before you make the suggestion. Many of you will be thinking of ways in which you can use this technique in your exam. After this introductory demonstration, I'm sure you can begin to think of ways we can all use this in everyday life. Phrasing a question to include a suggestion so that the person in the question is directed to it will think of what you want. I'm wondering how quickly you will all begin to learn this. Would this now be an opportunity to do something? Mentioning a desired state of mind or emotion that you want in your suggestion may help your listeners to encourage that state of mind by bringing it to the attention of the person you're talking to. I'm curious to know when you will enjoy number bonds. I'm a bit anxious about using next one because I know someone didn't like the word fun. Another fun way to do this calculation is or another quick way. But you can see why they've used fun, because they want their adult learners to begin to enjoy maths. And reframing them things so that make them sound possible can help overcome barriers to thinking. So what would it be like if you were able to do this? If you did know the answer, what would it be like? If you connect a suggestion to something that is undeniably true, it is likely to make the suggestion more likely to be accepted. Completing this activity, and you've done that, means that you will find the next one much easier. Now that you know you can work out equivalent fractions and know what a percentage means, that percentage means out of 100, you'll be able to turn simple fractions into percentages. So by saying you are able to do that, and they are saying yes, it will help them. Yeah, so yes tags, which is what I've started to talk about, are very useful. If you can say yes to the first one, you're more likely to do the second. Now you can multiply by 100, you can divide by 10, can't you? Your group had the correct answer. Now you could make up similar questions, couldn't you? This is a quick way to do the calculation, isn't it? And because they've said yes to the first thing internally, they are more likely to say yes to the second thing. In fact, you can take that to another further step. If I say, we are all watching this webinar at home, we're at the Scottish Maths Council conference, and I think that you will want to use some of these techniques in the classroom. Because you've said yes to the first thing and yes to the second one, you are much more likely to say yes to the next one as well. You've learned about the cosine rule. We've done some examples. Now would be a good time to practice examples by yourself, wouldn't it? And they're more likely to say yes internally. You've carried them along. So in the classroom, so let's have a try at writing our own example. Think of a yes, yes, yes example that you could use in your own classroom and write it into the chat box. And I'll give you a couple of minutes to do that. So you might start off, I'm standing, we're here in such and such a school. It's a lovely sunny day. And now we're going to understand and learn how to, or something. Have a try. It would be so lovely because normally I would have said to you all, now I want you to go into groups and come up with some yes, yes, yes questions. But unfortunately, that's not possible today. So this is my attempt to make it feel a bit like that, but not quite. Right, well, again, I'll stop you there. But again, if you want to afterwards add something in the chat box, please do. Command with a question. If you take your command and turn it into a question, it actually softens the command and helps it make it more acceptable. Can you think of a question to ask? Can you work more quietly? Could you put your pens down, look at me and listen? So all those soften the suggestion. People, as we've said, do love praise, and it's always useful to try and use something like "that's right" frequently when you see behavior you like. And also, when other people hear the praise, they'll want to copy the action to get your approval as well. That's right. Label the X and Y axis carefully. Talking quietly in group, that's right. So in fact, there you see they've added on "that's right" to what they were going to say anyway. Now, this was something that before I knew about NLP, I always practiced. If you give pupils a choice, then they will actually be more motivated to do the thing that you want them to do. So I used to say, particularly to the disaffected youngsters that I was talking about, and by the way, I should say that taking these 4 disaffected youngsters in from our feeder schools for a day a week earned us the undying love and affection of the teachers involved. Because if you imagine your 4 worst pupils are taken out of your school for a day, it does make a big difference to the rest of the school. Anyway, if you say to them things like, right, we've done that topic, we've talked about it, and now you're going to do the exercises, and you can choose whether you want to do the odd questions or the easy questions. So you allow them to choose what they want to do, or which maths worksheet. You can choose which one you would like to do for homework. You can choose whether to do worksheet A or worksheet B, or would you like to use the traditional method of multiplication, or would you like to use the grid method? In all these cases, I couldn't care less which one they choose. When I used to say to them, I want you to do the odd questions or the even questions, I couldn't have cared less which ones they chose to do. But because they had chosen to do the odd questions, for example, they seemed to be more motivated to do that because they had chosen to do it. So it's always useful to give people a choice without a choice. So they think they're choosing, they then become more motivated to do that, but actually it didn't matter to me, or it doesn't matter to you. And presupposing pace is also very useful. You can suggest the pace you want and assume it's going to happen. How quickly can you pack up the activity, I wonder? So you're assuming that they're going to do it more quickly. How quickly can you finish the questions? By saying that, you're actually assuming that they're going to do it quickly. And according to neurolinguistic programming, that's what will happen. They'll be more inclined to do it. And counting down. Now, I don't know about you, but I used to use this a lot when our children were small. I would say, I'm going to count down from 10 and I expect you to finish tidying up before I get to 1. Amazingly, I don't think I ever got to 1. I did become quite slow between, and I used to put fractions in, but there was this feeling that something might happen when I got to 1, and we never found out what that was. So counting down in steps to success in this lesson, we have a 5, look at me now. 4, listen carefully to the instructions. 3, think about how you can work quietly through these examples. 2, while you're thinking about the work that we did last lesson. 1, and we're ready to start now. When you're someone is putting you into a hypnotic state, they count down, and this is just the same. So counting down through the numbers actually begins a process of acceptance in the listener. And it's a typical feature of hypnotic induction, and equally it will work in the classroom. Lastly, I want to just talk about body language, mirroring. Look at these 2 pictures of Clinton and Joe Biden, and they are completely mirroring each other. That's what we do when we like someone. And if you're ever interviewing or doing a one-to-one with a student, it's really useful to actually mirror their body language, because we mirror the body language of people we like. Therefore, if you mirror their body language deliberately, they will feel that you like them. They will actually be more accepting of what you're saying. And similarly, if you nod in agreement to someone, again, we tend to nod if we agree. If we do that deliberately, it really does help them to feel more confident and also to get your point across. So nodding can be very useful. And just a couple of jokes to finish. I just hope that your students, your pupils, don't ever say this to you. And even more, that they don't do this. I'll just read this in case you can't read it. I did like it. First, I looked in the back of the book, but it wasn't an odd numbered problem. Then I asked my little brother, but he wanted me to pay him $5. Finally, I found it on the internet with Google. She's writing it all down, and she says to her brother, my maths teacher wants us to show how we get our answers. She's misinterpreted it. There are so many things that we can say that imply something else. I hope I've made you think about what we say in the maths classroom, what we imply, and the language we use, and what we should be saying. Thank you very much.